Welcome back to another explainer. So today we're tackling what is honestly one of the most frustrating bottlenecks in the entire digital world. But more importantly, we're looking at how it's actually, finally, getting fixed. We are demystifying Layer 2 scaling solutions. And don't worry, we're going to do this without drowning in a bunch of overly technical jargon. My goal today is to give you a really clear, structured map of how rollups, sidechains, and validiums are basically transforming the blockchain from a super congested, wildly expensive highway into a smooth series of high-speed express lanes. Okay, let's just jump right into this by starting with a feeling I know we are all way too familiar with. Why on earth should it cost $50 just to send $20 on Ethereum? I mean, if you've ever tried to mint an NFT, or maybe swap tokens during a huge market rush, or literally just move your own funds around when the network is busy, you have absolutely felt this pain directly in your wallet. It doesn't exactly feel like the future of money, right? It feels more like a ridiculous toll booth. When the network peaks, gas fees just skyrocket to these absurd levels. And what that does is it effectively prices out everyday users, while the whales moving millions barely even notice the fee. And honestly, the reason for all that intense wallet pain really comes down to this one number right here, 15. That is roughly the maximum number of transactions per second, or TPS, that the base Ethereum Layer 1 can actually handle. Now, you might be thinking to yourself, well, why so slow? We have these massive computers today. Well, it's actually an intentional design choice. To keep the network truly trustless and completely decentralized, every single one of Ethereum's 8,000 plus nodes literally has to process every single transaction. To put that into perspective, just look at this. This brilliantly illustrates the true scale of our problem. Contrast Visa's 24,000 transactions per second directly against Ethereum's 15. Because space on the Ethereum Layer 1 is just so incredibly limited, every single transaction essentially enters a block space auction. You aren't actually paying for the computation. You're basically paying to cut the line. So when 1,000 people all want to swap at the exact same time, they bid against each other. And boom, that drives the price up to those $50 or $80 fees we were just talking about. Now, you might be wondering, why not just make the blocks bigger? Like, if we just raise the gas limit by 10 times, wouldn't that just solve the whole shebang? Well, think of it like the Supreme Court. Asking the Ethereum Layer 1 to handle every tiny little game move or token swap, it's literally like asking the Supreme Court to settle every single parking ticket in the country. It would completely clog the system. If we just arbitrarily increased block sizes on Layer 1, the hardware required to run a node would skyrocket. Instead of just using a normal PC, you'd suddenly need a $15,000 server. And what happens then? We'd effectively hand control of the entire network over to massive corporations like Amazon Web Services, completely destroying the very decentralization that makes blockchain valuable in the first place. All right, so we can't change Layer 1. Instead, we have to build cities around it. And this is exactly where Layer 2 rollups come in. Think of transacting on Layer 1 kind of like paying a bartender for every single beer individually, plus handing them a heavy $50 gas fee each time you order. It's super painful. A Layer 2 rollup, on the other hand, acts way more like a bar tab. Thousands of transactions are happening, but the bartender just keeps a tally. Then at the very end of the night, you settle up just once, and everyone at the bar basically shares that single transaction fee. So let's break down how this actually works under the hood. It's a brilliant, really simple 1, 2, 3 process. First up, users transact on Layer 2. This is super cheap, takes maybe 2 seconds, and feels pretty much just like using the regular internet. Second, you have a centralized server called a sequencer, and its job is to batch thousands of these little transactions together. Finally, step 3. The sequencer compresses all those bundled transactions into one tiny proof and posts that down to Layer 1. And then, those 8,000 Ethereum nodes step in to secure that single summary. So the end result? You get the unbreakable security of the Ethereum vault, but you're only paying pennies because, remember, you're splitting that receipt with thousands of other people. Now, within this whole rollup space, you're mostly going to encounter 2 main types: Optimistic Rollups and ZK Rollups. So optimistic rollups, they act a lot like our traditional court system. They just assume all transactions are innocent until proven guilty. Because of this, there's a 7-day challenge window where anyone can flag fraud before you can actually withdraw your funds back to Layer 1. ZK rollups, however, are totally different. They're more like a brilliant student who instantly shows their complex math homework. The math itself absolutely proves the transactions are valid in mere milliseconds, meaning you don't have to deal with that 7-day waiting period at all.
All right, moving right along, let's look beyond rollups for a second and talk about sidechains and validiums.
Rollups are amazing, for sure, but they aren't the only tool in the shed. We're transitioning here into environments where users might actually be willing to trade just a tiny bit of that ironclad Ethereum security for even cheaper, lightning-fast transactions. And the exact trade-off here is really fascinating. See, a rollup posts all its data directly to the Ethereum Layer 1, meaning even if the Layer 2 company literally vanishes tomorrow, Ethereum itself can still reconstruct your funds. That is maximum security. A sidechain, however, like Polygon, for example, doesn't post all that data. It only posts a checkpoint. It actually relies on its own small group of, say, maybe 100 validators. Because of this, it is easily 100 times cheaper than a rollup, but you are trusting that smaller group of validators not to collude, rather than trusting the entire global Ethereum network. So the absolutely crucial point here is that there's no perfectly secure, infinitely fast network out there. There's only the right network for your specific risk tolerance. Think about it. If you're playing a crypto game and moving around a $10 digital sword, a sidechain is totally fine. If the validators vanish, you lose a $10 item. No big deal. But if you're moving $10,000, you absolutely want to roll up for that inherited Ethereum security. And hey, if you're a massive whale moving $10 million, you stick to the battle-tested Layer 1 vault or a highly mature rollup. Always match your security to your value.
Okay, next up, let's jump into a practical guide and actually meet the big four Layer 2 networks.
All right, so now that we've kind of got our heads around the architecture, let's equip you to choose the exact right network for your daily digital life. Let's run through the big four. First up, we have Arbitrum. Think of Arbitrum as the DeFi king. It's an optimistic rollup with the deepest liquidity and honestly the most apps. If you want to trade or earn yield, this is where you go. Then we have Base. Built by Coinbase, this one is hands down the easiest for beginners, mostly because you can move fiat money, like US dollars, onto it in about 60 seconds flat. Optimism is super fascinating because it's building this massive superchain vision, basically aiming to connect a bunch of different Layer 2s together seamlessly. And finally, ZK Sync is leading the pack in ZK technology, meaning those complex math proofs we talked about, and absolutely no 7-day waiting period to withdraw your money.
Which brings us to actually living on Layer 2, how to bridge your funds, and most importantly, how to stay safe doing it.
So you know the networks now, but how do you actually get your funds onto these new express lanes safely without falling victim to the various risks of this newer frontier? Getting your money from Layer 1 up to Layer 2 requires what's called a bridge, and this is honestly a vulnerable step, so you've got to choose wisely. Option 1 is using the official bridge, like Arbiscan for Arbitrum. This is absolutely the safest route, but remember, for optimistic rollups, withdrawing back out is going to take 7 days. Option 2 is a centralized exchange like Coinbase. This is the fastest and definitely the most beginner-friendly. You just send funds directly to the Base network, for example, with 0 wait times. And option 3 is a third-party bridge. These are super fast and cheap for jumping between different Layer 2s, but they definitely carry a higher smart contract risk. So the main takeaway here, use a centralized exchange or an official bridge for your large amounts, but feel free to stick to trusted third-party pools for quick, really small transfers. Okay, before you move any real money at all, I want you to run through this quick L2 safety checklist. First, always check L2beat.com. You want to see exactly what stage the network is in. If it's stage 0, that means the developers still hold centralized upgrade keys, meaning your funds are totally at risk if those keys get hacked. Stage 2, on the other hand, means it's fully trustless. Next, verify that the network has over $1 billion in total value locked, or TVL, because that really proves it's been battle-tested by the market. And a pro tip, never bridge your whole stack at once. Start with just 5%. Test out the apps, and just make sure you can actually force a withdrawal back to Layer 1 if the Layer 2 sequencer ever goes down.
And that brings us to our final thought for today. The hardcore engineering work, it's been done. The express lanes are built. So now that fees have dropped from $50 all the way down to just 5 cents, how are you going to participate in the scaled future of crypto? We really no longer have the excuse that the blockchain is just too slow or too expensive. The cities have been built around the Ethereum vault, and they are wide open for business. I really hope this explainer empowered you to go out there and explore them safely. Thanks so much for learning with me today, and I will see you in the next one.